Okay, let's continue. So we'll look at functions and graphs. So let S be a subset of R. So S is some collection of real numbers. A function, we denote it like this: f from S to R associates to each input x in S a corresponding output f of x in R. So a function, so S is some subset of R. A function f from S to R associates to each input x in S a corresponding output f of x in R. So if there is some input x, the function f associates to it an output, a corresponding output f of x, which is an element of R. So x is in S, the inputs are in S, the outputs and the output will be in R. Okay. To each input x in S, you get a corresponding output f of x in R. So this is what a function f from S to R does. So this is what functions mean. And here the set so the set of, so let's say like this: note that the set of input output pairs is, so given a function f, the set of input output pairs is just x comma f of x as x varies over S. The set of input output pairs as x varies over S. This is a set in the plane. So the set x comma f of x as x varies over S in the plane is called the graph of f. So here is some set S, and you have some set of input output pairs. For example, this is one input output pair, x comma f of x. So this set of input output pairs is called the graph of f. So a function f from S to R just associates to each input x in S a corresponding output f of x in R. And the set of input output pairs, if we plot it in the plane, that is called the graph of f. So that's all. Again, to emphasize, graph of a function is the set of input output pairs of the function. Okay, so let's look at some examples. So we'll start with simple functions. We'll just consider simple functions from now. So consider the function f maps from R to R and f of x equals 1. So it takes inputs from R and gives output corresponding outputs in R, and for any input x the output is 1. So consider this function. It's a very basic function, so it's a valid function. And what is the graph of this function? Note that the graph of f is, so it's the set of all input output pairs. So for every input you are getting the output 1. So a generic point will be x comma 1, a generic input output pair. For example, if you are giving it input 1, it will still give you 1. If you are giving it input -1, it will still give you 1, and so on. So this is the graph of f. So the graph of f is the set x comma y, where y is 1. This is the graph of f. So we simply write, so y equals 1 to denote the graph of f. That's also valid. Okay. So saying y equals 1 just means the set of all x comma y such that y equals 1. So okay, so this is the graph of this function f of x equals 1. So let's consider another example. Consider the function f mapping from R to R, and this time we will take f of x equals x. Whichever input it takes, it will give out the same thing as the output. So note that the graph of f is, so what is the set of all input output pairs? If you give it input 1, it will give output 1. So 1 comma 1 is an input output pair. Then if you give it input 2, the output will be 2. So 2 comma 2 is an input output pair. If you give it input -1, it will output -1. So -1 comma -1 is an input output pair, and so on. So whichever input you give, it will give the same output. So this is the graph of f, this line. Okay. So the line is just y equals x, the set of all points x comma y such that y equals x. This is the graph of the function. So this is another basic function, and we can look at one more basic function. So consider the function f maps from R to R, and f of x equals x square. So it takes input x and squares it and gives it as the output. So what's the graph of f? Note that the graph of f is, again, the set of all input output pairs. So at input 0, it will give the output 0. At input 1, it will give the output 1. At input 2, it will give a large output, so 2 comma 4. At input 3, it will give an even larger output. At input 3, it will give an output 9, and so on. So it will just keep on. And at input -1, you will get an output of 1 again. At input 2, you will get 4, and so on. at input -2 you get output 4 and so on. So you get some curve like this intuitively, which rapidly grows, and at input 10, for example, you will get output 100, at input 20 you will get 400 and so on. So okay, so this is intuitively speaking, so roughly speaking, this is the graph of the function, set of all x comma y such that y equals x square. So the graph of the function is y equals x square. So this is how the graph looks like intuitively. Okay, so yeah, so that's all about functions and their graphs. Okay, maybe we can make some more observations. Note that the graph of a function gives intuition about how the outputs vary with the inputs. So for example, by looking at this function f of x equals x square, we can actually immediately see, without even the use of a graph, that as the inputs get larger, the outputs get quite much larger than the input, and f of some negative input will also some, for example, f of 13 and f of -13 are same and so on. So we can make some basic observations without the help of a graph, but the graph makes it visually easier to see how the outputs vary with the inputs. So this is the main function of a graph. It gives us intuition about how the outputs vary with the inputs. So just for some more intuition, we'll look at one more example. Consider the set S, which is just the set of all reals which are non-zero. Then consider the function f from S to R and f of x equals 1 by x. So this function is not defined at 0, and for every input in S, so points in S are just reals which are not 0. For any input x in S, it gives the output 1 by x. So what is the graph of note that the graph of f is so for example, at input 1 you get 1. At some small input, let's say 1 by 100 or something, you'll get some very large output, so 100, something very large. So 1 by 100 comma 100 is also a point on the graph. Then at 2 you get 2 comma half, output half. At some very large input, say 100, you get some very small output, so 100 comma 1 by 100. So intuitively the graph will look like this. This is one portion of the graph, and similarly for negative inputs. So for example, let's consider -1 by 100 as an input, then it will output -100. So we're just, this function is just f of x equals 1 by x. So at -1 by 100, its output will be -100. So it will be some point here in this region. At input -1, it will output -1. So -1 comma -1 is a point. At input -2, it will output -half. At some very large, so some -100 or something, it will output a very large negative number, it will output a very small negative number. So for example, at -100, it will output -1 by 100, which is some point here. So intuitively, this is the graph of the function f of x equals 1 by x. So the graph is just the set of all points x comma y, where the second coordinate y depends on x as 1 by x. So the graph of the function is just y equals 1 by x, the set of all points x comma y such that y equals 1 by x. This is the graph of the function f. So okay, and so we looked at functions and some functions and their graphs, and we'll just make a note. So for example, if you have some curve like this, okay, and this is not the graph of any function, because if you look at some point with some input x, you are getting 2 points on the curve x comma y1 and x comma y2. So for an input x in S, you are supposed to have only one output f of x in R. But for suppose this cannot be a graph of a function, because at input x, so graph of a function typically should look like, for a given input x, it should have only one point on the graph, which is x comma f of x. It can't have x comma, for example, at input 1, the graph can't have both points 1 comma 1 and 1 comma 4, for example. So there can only be one input output pair. X comma f of x. This is not the graph of any function f, because there can only be one input output pair x comma f of x for the input x. In the graph, for the input x, there can only be one input output pair x comma f of x. So this curve cannot be, this curve is not the graph of any function f. Okay, so that's all for this part. See you in the next part.